Welcome everyone. Welcome to the July PyData Boston Cambridge Meetup. Today we have Eric with us as presenter. He'll be talking about his favorite topic these days, which is tooling and workflow management in data science. But before we begin, just a little bit of logistics and general information about the group. Um, our information is available on meetup.com by the name of PyData Boston Cambridge. We try and use constant hashtag PyData Boss for LinkedIn and Twitter handles. We don't have a Boston specific website yet, but we still go by pydata.org as our official website. I'll go through the code of conduct, but in detail, it's available on this link, which in the very short form is just about the fact that we are part of NumFOCUS as a bigger organization, and we are here to learn and develop ourselves professionally. We want to be kind to each other and just treat everybody else as if you would want to be treated by others. So let's keep all of that in mind. No foul language, no harassment. Let's keep it a welcome community where we are here to make friends and network and learn from each other and grow. um, Again, we always are open for, we're always looking for organizers. So please jump in if you're interested, if this talk is of interest to you. Plus, if there are other things that you would want to, hear about, let us know. Get in touch with us. We have a Slack channel, which is in this case, we have put in at the end, but this link is also available on the Meetup invite that you have RSVP'd with. We are always looking for speakers. We have slots open for August onwards timeframe. Companies can reach out to us in terms of partnerships. Right now we are all online, but we can think of ways. So earlier it used to be partnerships and sponsorships for food and venue. But yeah, I guess it will come back as part of this when we get to doing the in-person meetings again. The site I already mentioned. Yes, so we're having a PyData Global 2020 conference in November between 11th and 15th. So this is just a shout out and call for proposals, which is open right now. So if anyone is interested in, preparing and giving a talk, please go ahead and use this link to see the further details. And, I think we would love to have people from our community talk about what they've been up to. So again, now back to what we are all here for. We are going to hear from Eric about the principles of data science workflows and toolings and things that he has been developing over a period, from his experiences, things that he has learned, and he would help us not make the same mistakes, hopefully. So Eric is an investigator, focusing on data science and statistical learning at Novartis Institute for Biomedical Research. He's passionate about solving big biological problems with Python code, Bayesian statistics, and deep learning being his main focus areas. You can follow him on Twitter, LinkedIn, and GitHub. I've shared all those links on the Meetup page as well. And I'm assuming he would have in his presentation as well. So I think this is another interesting one. So we have some goodies for today. At the end of the session, we would, if you stay until the end, we would be raffling a book that Eric has co-authored with Mridul Seth. I think we had a link. We would probably post it on the chat. But we have created a Google form if you would want to be, if you would want to participate in the raffle. So there is this book, and then we have another book. I'm sorry, but I'm forgetting the name. It's, I think, Essentials of PyCharm by Matt Thompson. So we have created a Google form which we would share. I think Tyler might just ping there. Which basically you can show your interest if you're interested in raffling for one or the other book, because everyone just gets one chance. We have 2 copies of both these books. And I think that's all from my side. Over to you, Eric. Take it away.
Okay, thanks, Priyanka. So let's see here. First off, I'm gonna have to share my screen. In the event that you want to follow along and just hear the audio, you definitely can look inside this Zoom chat and you'll see the link to the slides there as well. I tend to do everything by I tend to do everything by HTML slides nowadays. I really detest PowerPoint at this point. So let's see if I can get this shared. I do need to, oh, that's a first. I have to allow Zoom to share my screen first. Well, I guess in the meantime, y'all can open up your slides via your own browsers first. This might take me a moment or two. I should have tried this beforehand. My apologies. I'm using my personal laptop, so I haven't, and Zoom is giving me the beach ball of death.
Okay, I think I'm able to open it. I can try sharing this if you want. And
I think that's worth a try.
okay.
Thanks, Bianca. I'll just have you, I guess, move slides. And if you'll just
Yep. I'm trying to
give
see if I
me
can give you a right
one
to move as
more
well.
minute, I might be able to do this.
Okay.
Okay, it looks like I actually do have to rejoin the Zoom. So I'll come back in a moment, okay?
Zoom.
I
Okay.
think
I think
we're
we're
good
good to
with
go.
that. Okay, so all right, let's get started then. So, hi everybody, I'm Eric, and I work for Novartis for NIBR, Novartis's research arm. I've made a lot of mistakes in the past, and I wanted to share some of my lessons from making all of those mistakes. So, if we could go to the next slide, please, Priyanka. Spacebar, simple spacebar will do the trick, and then shift spacebar will bring us back in case we need to. So the main, just so that you have a little bit of where I'm coming from, the main object of my work is to accelerate biological and chemical research. We're hunting for medicines. There's a molecule or a class of molecules out there that solves diseases, and we want to be able to find them in a fast way. The hypothesis right now is that machine learning methods will help us. And so I try to bring in principled statistical workflow as well as robust machine learning workflows into my day-to-day work. And so that's the main focus right now. And if we go to the next slide, that's where oh, that is kind of weird. Priyanka, can you refresh the slide deck, please? Refresh
Okay.
the browser.
Sure.
Because it would have, I've updated the slides with a Git push pretty recently.
Okay.
So, and it's me trying, oh, no, don't hit the right button, hit spacebar. Just hit spacebar, and
Oh,
that's good
okay.
enough.
Yeah.
Yeah. All right, cool. So yeah, I'm a data scientist, and the reason I've made all these mistakes is because I've also had to play every single role that you can think of in a data science context. So I work on protein engineering projects, so therefore I've played protein engineer, helped design experiments with my bench colleagues. I've played data engineer because I was part of a 3-person team that supported the development of the project. We've had to build our own software. We then have to go on and decide, what machine learning methods we're going to use, go and benchmark them. We've had to deliver presentations. And so that's sort of a little bit of where I'm coming from. All of the mistakes that you can imagine. So if we go down 2 slides, just hit spacebar twice. I wanted to talk about give a little few words of encouragement with respect to the open source world as well, because I myself have benefited tremendously from it, and I want to make sure that I encourage more people to contribute to the open source world. In terms of where I come from, what I work on in the open source world, moving on to the next slide,
All right.
there's stuff
Sorry.
I've worked on with PyJanitor, for example. Bianca, if we could move to the next slide, please. No, it's hit space, please. just hit spacebar. You don't have to use the mouse. One of the things that I work with, I've helped develop is this package called PyJanitor. It's sort of a package where we're trying to bring a much cleaner API to data cleaning, method chaining and the likes. You can click on the link in the slides if you want to check it out. It's very beginner friendly to contribute. There's a lot of very user friendly functions that are inside there. Also, the programming model is really easy. If you have a function that you want to contribute, it literally is you implement the function, and then we'll work with you to make it like robust, well documented, tested, all of that good stuff. And it's actually been my training ground plus practice ground for software development workflows, which have really influenced how I do stuff nowadays. Going on to the next slide, we'll see, I'm also really passionate about educating and teaching things, and Network Analysis Made Simple is an open, free project. And I want to encourage those of you who have things you feel like you can teach, go and make these open teaching materials, open educational resources, because they're really great for one, brushing up your own knowledge, and two, sharing the knowledge with others, and three, getting knowledge that stuff out into the public domain, right? And it's a really great way, if you're inclined this way, to go and help build basically help build your public portfolio. So it's a great way to do that. On the next slide, we'll see that we're giving away two copies of that book. So you can if you stick to the end, then there's a chance to get a raffle for it. And then down one more slide beyond that, if we could move on, Priyanka. And one more down, sorry. There's another one that we're trying to write. It's all the lessons we've learned, me and another colleague, Zach. He and I have stumbled through it since grad school. We were in grad school together. It's up on LeanPub, and if you'd like to read it, there's a sign-up form on LeanPub that you can tell us, like, hey, I'm kind of curious about what's happening there. Okay, so if we move on, I want to, if you hit spacebar, please, the thing that we're going to go through today is what I call principled data science workflow. And it's basically everything outside of importing scikit-learn and building your model. Like, I'm assuming if you're in a data science position nowadays, doing data summaries, pulling data with SQL, building models, building predictive and or causal models, and delivering on projects is part of your day-to-day. But as I've learned from work, there's a whole, that's like the core of what we do, but there's a whole bunch of stuff outside the core that can really accelerate our work in the core. But if we ignore it, then we're going to be hampered in how fast we can move. So the 5 principles that we'll be going through today are really principles that relate to the workflow outside of the core, right? So first off, it's about starting with what a defined impact is and going to look like. The second one is to stick to pretty sane conventions that are, human first conventions. The third is to develop in such a way that we're not like, we can move from computer to computer. We can develop in a pretty portable fashion. And then the fourth is to really invest a lot in automation. And the final one is to be very picky with defining sources of truth, because your data sources can get, for example, wildly out of hand if you're not careful. So those are the 5 things we'll go through. Each of them has been backed by a lesson that I've learned in the past, all right? If we go into the next slide, one thing that I just recently learned about from the book in a different context is this idea of Liebig's law of the minimum. So how fast your team will go is dictated not by the total richness of your environment, but by the limiting factor. And it sort of makes sense. If you know anything about plants, you'll know that if there's something that limits its growth, that's going to cap its growth. And it actually follows pretty naturally from the laws of biology. What's your rate limiting reaction? What's your rate limiting step? Right? Your data projects, think about them in a holistic fashion. There's all these things that can help you make your projects move faster, be much more robust, be all around better. If you don't spend time on them, then you're just going to be limited by whatever is limiting the full potential of your projects. So if we move on to the next slide, I want to go through a few screenshots. These are screenshots that are snapshots of my past. And I want to engage in a bit of dialogue with you. When you look at these repositories, so let's look at this first repository on the next slide. Right? It's a thing from grad school. 5 years ago, I did this project. Can I ask, when you look at a repository that looks something like this, what looks wrong to you? Can you put that in the chat? Yeah, let's put that in the chat and then tell me what looks wrong to you. So Venkatesh has a lack of organizational structure. Yes, absolutely. No hierarchy. Thank you, Lar. It's a long list of stuff. You hit the viewer with like stuff. Francis is telling me I should have code packaging. And Sandy goes, I have no idea where to start. Exactly. That's really good. You picked up on it. And Anne has this comment. Looks like you only did one commit, basically. Yeah. Published it and didn't really use Git at all. Exactly. This is me 5 years ago, right? We go to the next slide. Tell me what looks wrong here. In chat. This one's a little bit not so obvious. And unfortunately, you can't scroll down, but you can look for the repo if you want to. So Ben's going organization, notebooks, scripts, etc. Right? So there's a little bit more organization, but it's still lacking something, right? Exactly. There's also, you'll notice someone mentioned library files. There's no custom source, which is well-defined that I can install. I'm lacking a proper full-fledged data science environment. I mean, I have a requirements.txt, but it's not really used for anything. And so this is 3 years ago, not 5 years ago. This is when I got burned by installing stuff into the system Python environment and then promptly broke iPhoto because iPhoto broke when I deleted the system Python and tried to start over from scratch. So then I learned, okay, I should maybe use an environment manager, picked up Conda and started doing things. But even then, good habits were not necessarily ingrained. All right, so if we go to the next slide, let's see, continue the critique. What else is bad about this one? Okay, Venkatesh is very astute with that. I'm missing instructions, missing how to recreate the environment. The README is kind of uninformative. Exactly, yeah, it's another snapshot from my past. So you can see, and when I was first, and by the way, I'm not shy about this. There's a reason why I've taken screenshots, and none of these repositories are private. You can actually go in and dig into my history and find that I was once a really bad developer. And I was once not so well versed in all of these best practices that I'm going to talk about. And that's there to hopefully ease the pressure and give you a bit of encouragement. Everyone starts somewhere. So, and we're going to go through all of those principles in a little bit more detail, but everybody starts somewhere. And everybody, because they've started somewhere, they're going to have a history that looks something like this. And it's completely fine as long as you are on an upward trajectory, okay? All right, so let's go down 2 slides and let's take a look at this. Yes, exactly that. So when you approach a new data project, what I find is I've oftentimes got a bunch of questions to which, by the way, all of the examples that I showed above, they will be negative. They will be negative answers. So let's take a look at and see what some of these questions are. All right, so if we go to the next slide, that first question we might ask is, we hit a repository and we're going like, well, okay, where are these things located? Where is the Jupyter notebook, right? Where is the custom source code? Where's the documentation for the project? And if you might be wondering, why do I keep harping on the custom source code piece? Well, there's a reason for that. With the custom source code, imagine you wrote all of your stuff in Databricks notebooks, right? The Databricks UI, I'm not sure whether you've experienced it before, but I have. It encourages all of your user-defined functions to be inside the notebook. And what does that mean for the readability of the notebook? The notebook is essentially unreadable, so you need a custom source code package. And notebooks like Python code are intended to be read. And if you're gonna make things difficult for a person coming into your project, then it's kind of defeats the purpose, right, of writing notebooks. So in any case, that's why I'm so insistent on custom source code and building a Python library that supports the project. And more generally, I want to know, where are the notebooks? Where's the custom source code? Where's the documentation for the project? And where's all these other things, right? If we go on to the next slide, another question that I might have when it comes to a data project is, I'm curious to know what the latest status of the analysis is, right? Where is the dashboard or web app that powers serves up, not powers, serves up the analyses results? Even if it's in Spotfire, where can I go and take a look at where it's located? Another thing I want to know is the thing that I might see on a dashboard of some kind or a web app of some kind, are the analyses up to date? Those things up to date with respect to the latest data? How can I go back in and track and see, without needing to bother people too much, what the latest status updates are? And if you adopt tooling such as continuous integration tooling, you actually get a programmatic way of knowing some of these answers. Moving to the next thing, as some of you correctly pointed out, there are no instructions to recreate the environment, and launch a Jupyter notebook, and be able to re-execute things. So that's one of the things I want to look for. Where is the environment.yaml file, right? If there's an environment.yaml file, immediately it's extremely idiomatic what I'm supposed to do. Or even if you have things that are a little bit more complicated, and you need more than just what Conda can provide you, where's the Docker file, right? Even with the Docker file, there's a standard set of idioms that are provided that make it very easy for a newcomer to the project who is also well-versed in a bunch of these community idioms to come in and recreate the environment and start being productive pretty quickly. And even better, where's the 1 or 2 line bash command, right? That's sort of the convenience stuff that you want to provide to your future selves or to other colleagues. Moving on, there are more questions. There's data involved. Sometimes if your data file is small enough, you can commit your data inside the Git repo. I don't always encourage that. I think there's got to be better ways for data storage. But in a pinch, if you really needed to and you wanted the entire project to be portable from computer to computer, you can just put a small CSV file inside there, and that's cool. But then if you've got stuff that's on S3 or in a database, where are the instructions that tell you how I should get access to the data, right? Where's the Parquet file that I should be targeting, right? How do I get the necessary access to that? These documentation pieces ought to be inside there too. And then if we go on, there's another question. How do I know if you've got custom source code inside your project? So we move on to the next slide. If I've got custom source code inside the project, how do I know it's correct, right? How do I know how to use it? Your test suite will tell me, but how if you don't have a test suite, how am I supposed to know? If I see copy pasted functions from one notebook to the next, how am I supposed to know whether the intent here was that they're supposed to do the same thing or they're actually different things? It's really hard to tell, right? Without closely examining the code. But if you have a custom source library, you can install flags, that help you modify the behavior of the function in a very principled fashion, and make it much easier for someone coming in to read your notebooks. Okay, so those are the set of questions, and they all come from me going into another project and then realizing, oh shucks, I don't know what I was supposed to do, or me looking at a previous project that I worked on and then coming back to it, half a year or a year later and going crap, I totally forgot what I'm supposed to do to recreate the environment. I don't think I trust my source code. And more than once at work, I've actually rewritten projects from scratch, and because they weren't done the right way, they weren't done in such a way that I could come back later and pick up on it. I think we underappreciate that. So let's talk about the principles. The principles, we start with the first one, which is this notion that it's really important to define impact. Modeling work, at this point, if you're using tools like PyCaret and the likes, or Auto, sklearn, modeling work is the least of your problems. The biggest source of frustration for data scientists that I've seen is that we work on models and no decisions are taken on the basis of it. We work on models and there's no artifact that we deliver and hand over. So the first principle really is to define impact. And I have personal stories from it. If we go to the next slide, about 3 or 4 years ago, I wrote a graph neural network that operated on protein structures trying to predict HIV drug resistance. And that thing went nowhere because I didn't start with what do I really want to achieve. It remained as source code in an anonymous Git repository on my GitHub user account. And it just went nowhere. I did a whole bunch of stuff. I learned a lot of things about how to implement graph neural nets from scratch. And it gave me a very, very deep heads first education in that, but I have nothing to show for that. And that's because I didn't work backwards, starting with a defined impact. So if we go to the next slide, the thing that you want to take away from this project, from this principle, is always, always define what the impact looks like before you embark on a project. So the questions that you will want to ask yourself, for example, on the next slide, what decisions will we take on the basis of this analysis and on the basis of building a model? Nowadays, I actually challenge my colleagues first. Sure, I can build a model, but I'm not going to build it if it's not going to influence the experimental design or the prioritization of molecules at the bench, okay? So what decisions or actions will be taken? In addition to that, if you go to the next slide, we have to worry about what the artifact looks like. And here's why worrying about what the production artifact looks like matters. When you hand over an artifact, that brings closure. If you don't hand over an artifact, there's probably an order to 2 orders of magnitude less feeling of closure. So if you get a chance to hand over an artifact, that's a great way of bringing closure to the project. It allows you to say, there's this contract defined handover, I'm going to give you stuff. And then I can move on and worry about other interesting projects at work. And that's really what a data science team, I think, how they should be operating, right? It's a service organization. Come in, do one thing, help bring it to where that artifact needs to be delivered, deliver it over to the supporting organization or the client organization, and then move on to other really interesting and cool problems. Or at least that's what my team looks like and how I would approach what the team that I'm on looks like. So what do we mean by different types of artifacts, right? Doesn't mean you build an API, right? So if you build an API and hand that over, that is a superb thing, right? Because, for example, you might need to build an API such that the software engineering team and machine learning engineering team can build other products into their like software, into the software that they're making for, you know, other colleagues or externally. If you go to the next one, it could be a software library, right? That has been part of the things that I've had to deliver to other colleagues. So for example, working on this protein engineering thing, we've built a custom software library, and we're seeing that parts of that library are actually really useful to other colleagues doing protein science. And so we can actually break that out into a shared library, start advertising it, share it with the others. They can install it onto their own Conda environments, and do stuff with it, right? It can be a dashboard. This is the next one is dashboard, and it can be something that, this is pretty much what we consider to be the canonical thing. I put it in the middle because I found this to be a little bit too bland for my taste nowadays. Dashboard's all fine and cool, but if they're not making decisions on the basis of your dashboard, it also is not that good. But anyways, it's a form of an artifact that you can deliver as well. Lo and behold, it can actually be the case that the Excel spreadsheet is the output. And don't underestimate Excel. Like, I forgot so much of Excel that in front of my accounting colleagues, they think I've got Python wizardry. I think they have Excel wizardry. They know how to do so much stuff in Excel. And Excel is like the one place that is readily available for non-technical colleagues to be able to really quickly dive into the data and have productive conversations with us, right? And sometimes that's necessary. And if that means you need to export an Excel spreadsheet and hand that spreadsheet over, that's a totally legit endpoint as well. And guess what I found out as well? Apparently in RStudio, I'm a Python person, but in RStudio, there's this ability to generate emailed reports that get sent automatically from the RStudio server into your leadership's inbox. And if that's the endpoint that they need, and you've mutually agreed on it, apparently the tooling also exists to do that, okay? So those are just examples of some of the kind of outputs. And if you know, if you see the pattern here, the model code is sort of the core, but there's a whole bunch of supporting Python code or R code that you have to write in order to make this deliverable a reality. So surrounding a data science project, if you go to the next slide, this really important point here is that surrounding the data science project is often just a bunch of software that sometimes we have to write to fit the context that we're in. And if we're going to write all of this software, we might as well learn some cool things from software developers who've had over 20, 30 years of modern software development, modern maybe 5 or 10, but 20, 30 years of like learning lessons that I think we data scientists can learn from, right? I recently picked up a book called, I think it's called Shape Up or something like that. It's linked in the slides if you mouse over that. It's a book that's geared towards software teams, but it's a free book that like really illustrates some of the really good workflows. It's written by the Basecamp leaders, Jason and David, Jason Fried and DHH, right? There's some really cool ideas inside there. Data teams will need to adapt some of those ideas. They're not 100% transferable, like mockups, for example, less relevant to us, but sure, that's something that we'll have to adapt. There's another thing that I learned from another friend of mine who is a software engineer at Celerity. If you go to the next slide, he advocates that we work, he advocates for developing software outside in, or working backwards from the endpoint to the core. And that's because the core of any data problem, or sorry, of any software problem, even though it's the most intellectually interesting piece, it's oftentimes also not the most impactful until it's connected way out to, you know, how people are going to use that piece of software. So in our case, it's in machine learners case, for example, the API might be one really important piece that we have to worry about if we're not using frameworks. Or the Excel spreadsheet, and you know, how we get from our machine learning model to the output that our end users want, that really matters. So working backwards is that principle. And there's a blog post that he also put in there. And one other lesson that I've learned is that from, for example, this graph neural net thing that I did in grad school, the most complex model is not always needed. You should deliver on the thing that's needed first before you go back and try to improve it. And then, even then, you should go and weigh the pros and cons of, like, in terms, not only in terms of model predictive accuracy, but also in terms of, is it worth the extra complexity, for example, to go and take on a deep learning project? To convert the model piece, which is like the intellectually interesting piece, into a deep neural net. Because if practically speaking, you gain a small amount of predictive accuracy, which translates to a small amount of revenue or time saved, is it really worth your large amount of time to go and practice that? If you're really looking for a deep learning project, stay patient. There's always going to be something interesting for which this trade-off becomes the right trade-off, where you can invest a lot, you might improve the model a little bit, but you get 100-fold improvement in your revenue or time saved or whatever. Okay, so that's just one other thing to worry about. Okay, so yeah, I actually just said all of the stuff that's on the slides coming up, so we can hit the right arrow button, Priyanka. So let's look at the second principle. All right, the second principle is to worry about conventions. That first principle was start from the outside in. The second principle is worry about conventions. What do I mean by conventions? I'm going to take you through an example. If we go to the next slide, if I have a project, a really sane convention is that everything related to that project belongs in one directory, right? And that one project, because it's one directory, it belongs to one Git repository on the next slide. Okay, so one project, one directory, one Git repository. Moving on, if you have one project, you have one Conda environment, okay? And then if you have one Conda environment or one project, then you have one custom source package for that project. And why do you want that source code package again? On the next slide, I say it. You want to minimize code duplication, single source of truth, easier to test. Basically, you're right. If you want to make things a lot more sane to manage as the complexity of your project grows, okay? If you write good software, you'll find that we're also writing well-defined categories of things. Yeah, if you think clearly about your software, you actually have a collateral benefit, which is you think a lot more clearly about your project as a whole as well. I'll give you an example. Data loading functions are a thing for me, right? And with data loading functions, with this protein engineering project that I worked on, I could have just stuck all of my data loading functions inside one .py file. Instead, no, we chose to separate it out by our data modalities. So we have the mass spec data on one side, the sequencing data on another, in another .py file, and then all of the related helper functions all organized well over there. So actually, when it comes to like us categorizing, bringing sane categories into our project, and then organizing our code in that particular fashion helped us actually reason about our project a lot more easily. So moving on, when you have one project, we've got a custom source package, but yeah, we also need one notebooks directory, right? And in fact, in the notebooks directory, one thing we've done is set up sort of like pseudo user spaces. Like I have a notebook directory under the notebooks directory that belongs to myself, and I don't touch my colleagues' ones, even though we can see each other's, right? It's a pseudo user space sort of thing. And that helps us keep the notebooks from cluttering the top level directory. Moving on, if you go to, because we have one source directory, we have one test suite that tests all of our code, right? I'm not going to go through in detail how to do that over here. I've got another talk that I did earlier this year at Ann Arbor that goes through how do you do testing practices for data scientists. But yeah, if you write code, you should test it. If you write data loading functions, you probably should validate that your data loaders work correctly as well. Moving on, If you have one project, you should have one README. And that one README gives a newcomer to the project the overview of what they expect to see, right? And then if we move on again with one project, there's also one documentation suite, right? So these docs are written essentially as markdown files. There's a bunch of tooling, opinionated tooling, that give you the ability to make very beautiful documentation sites. Network analysis made simple is actually an example of me getting practice with documentation. If you look at the site for network analysis made simple, we won't go there right now, but if you go there, it's like make docs material, it's got search, it's sanely, it's organized, there's a table of contents, and everything renders in beautiful HTML. So that's another thing. So if you're wondering, well, like, okay, do I have to remember how to do all of this the first time round? Or sorry, every single time? The answer is possibly, but if you go to the next slide, there are cookie cutters that allow you to create these projects in a quick and easy fashion. So, and by the way, if you master how to wrangle one, say for example, cookie cutter, that tool, then it'll actually help you to customize it to the level of complexity that you need. And you don't have to be stuck then with someone else's extremely opinionated cookie cutter. There's a tool I've been trying recently, which is Kedro. I personally think it tries too much to be a God tool, but I can see where its use case might be. So it's not lightweight enough for my tastes, but I can see where other people might find it handy. And I'd encourage you to go check it out. Moving on. So that's principle 2, which is to worry about sane conventions. And if you'll notice, it's essentially a very strong one-to-one-to-one-to-one-to-one-to-one mapping of stuff. One project, one Git, one docs, one source, one test, one README, etc. The next thing I want to talk about is this idea, this notion of being able to develop portably. And what do I mean by that? If we move on to the next slide, the essential idea here is that you want to be able to work on any machine. You don't want to be confined to just your laptop. And I can tell you why, because there'll be times when you want to access bursty compute. If you use Dask, for example, it'll let you, if you use Dask on a machine that has access to a compute cluster, you actually can use a tool called Dask Job Queue to spin up an ad hoc 500 worker compute cluster just for yourself that lives on the high performance compute cluster, and use that to take down workloads that may have taken a few hours to mere seconds, right? So Dask is really, really important. And if you want to be able to, work on any environment, then you need to think portably. So you might start, for example, on your little laptop. I'm on my little MacBook, or my MacBook Pro, that's my work machine. But at some point, I know that I'm probably going to need bursty compute, and I'll want to be able to move the project onto a Linux workstation that lives on campus at work that has the ability to burst into the high performance compute cluster. So that's one of the motivations. And if you go to the next slide, the other motivation here is that if you develop your project to be portable on any machine, the end product that you might have to develop, so for example, the API, or for example, this dashboard, it has a chance of also being portable across any machine. So you can actually deploy to the cloud if you need to, or you can deploy to an on-prem server if you need to. And you're not going to be confined by all the quirks and all the quirks that you might have about your local laptop environment. All right. So moving on to the next slide, one of the important things that you will want to consider is like putting in a sane baseline environment file, right? A Conda environment file. I actually have this inside text expander. So I do semicolon env, and then bingo, I'll get this entire thing put out to my text editor immediately. And that gives me a bunch of tooling that's pretty sane, right? So I have the basic data science stack. I got code quality utilities. I've got stuff that's, you know, good for documentation all inside there, and I can modify and update the environment as the project requires it. So that's one example. So one limitation of Conda environment files is that they don't worry about the operating system tooling. So if your operating system, if you do need things that are like operating system wide, then on the next slide is the solution. You probably need a Docker file, right? So I've seen projects, I think Emily, we worked through things for your Insight project as well, where there are some system-wide libraries that were needed you couldn't obtain by Conda. At that point, now you need to worry either about the deployment system or you need to worry about a Docker file so that you can containerize the entire project together. All right, so if we go down 2 slides, that's like a basic thing. I've actually started, in fact, experimenting with what software developers call development environments. It's still a little rough right now for, development containers. It's still a little rough for data scientists in that, you know, starting a Jupyter server and like worrying about ports from the container and that, like, that's still kind of a little bit of a rough thing. But in terms of at least packaging up the code such that it can be shipped and handed over, say, to a software engineering team for the full official productionization, this is like going to lubricate your interaction with them long term. All right. All right. So then moving on to the next principle, it's all about automation. So I wonder how many of you have had this situation where, for example, you get your notebooks are written, and now in order to check the correctness of your analysis, you have to manually step through the notebook cell by cell and like visually inspect, does it sort of kind of look right? Does the output look right? Did I accidentally change this function such that it does the wrong thing? That's human time that's being spent, that should be spent early on, but you should automate that so you don't have to spend that human time long term, right? Or how about that other one where I actually got data from colleagues twice, once in grad school, once at work, where the CSV file came in and all of my code broke as the new CSV file came in because suddenly they decided to capitalize the column names, right? That's the sort of thing that we don't want to check, right? By hand. We want a machine to be able to catch all of these things on an automated basis. So that's why this 4th principle is all about like automation. Investing on automation will help with the reproducibility and saving your time in the future. So if we take a look, doing things like saving keystrokes, mental shortcuts, those dividends help later on. And if we look at a few examples, one of my favorites is actually using makefiles. So if you, on the next slide, I got a few things you can do with makefiles. So for example, if I write a makefile that has an init command, then I can just do make init and it'll execute all of the bash scripts that are inside that block. Sometimes PyTest, if I have a complicated testing suite command, I don't want to remember it. I just want to remember make test, then it'll do that. In fact, there's a command that I wrote that is called make format. I didn't put this one here, but it's like I sort. So I sort all of my imports on my Python source files and then black with L79, 79 characters for the win. And that basically is me saving time and saving my colleagues' time as I try to onboard them onto the project. And so these little pieces of automation, they're worth it. They're absolutely worth it. Yeah, so that's and one of they're worth it because they make these complex bash commands easy to execute, but also because if you connect them with a pipelining tool on the next slide, they actually make your pipelining tools pipelining declarative commands a lot easier to write. So if you go to the next slide, you'll see it. You can have, for example, on Travis, instead of having to remember and copy paste like, I need to write PyTest minus VV -- cove and then blah, blah, blah. I can just right there make tests. And it's the same command on my computer. It's the same command on a remote machine that Travis or Azure Pipelines or Jenkins would use. The real thought behind all of this, by the way, is on the next slide. If you've got a defined production endpoint, I want to make sure that everything has to be reliable. And in order to make sure, but checking that everything is reliable is a really tedious task, right? It's essentially saying, this should have been as I saw it before. This should have been as I've seen it before. That other thing should have been as I saw it before. Why not automate it all? Why not save yourself keystrokes, right? So if we move on, there's another idea that I really want to share with, try to champion and encourage more people to embark on, which is this idea of writing tests for your data. It comes back to that column names thing experience that I had before, where I had data that came in with badly spelled column names. There are data that came in that were in Excel or CSV files that were miscalculated because someone updated the Excel spreadsheet formulas. And that just caused a lot of disaster downstream. It caused a lot of things to go to null values completely unexpectedly. So writing tests for your data is really important. And as I've studied more and more about Bayesian stats, I come to realize how data are drawn from a distribution, and that distribution is extremely messy. It's not one of your nice parametric distributions. Your data come in with null values, with misspelled things. Go see how many ways Americans fail to spell Philadelphia the right way. It's all over LinkedIn. So if you go on the next slide, Priyanka, these things can change under you and break in completely unexpected ways. So you better have a well-defined source of truth that allows you to automate the checking of your data. And so one of the things that I've encouraged before on the next slide is simple data tests. So if you have data loading functions, you write a test, say, for example, for the column set. You can do other things for the data types. If you don't want to do just the hacky things, moving on to the next slide, you can actually try things out with Pandera. And Pandera is pretty nice because it allows you to validate your data in a very nice API. I'm going to write a blog post about this pretty soon. So you can do schema validation. So for example, if you have a data frame that looks something like this, you go to the next slide, you can actually write a pretty sane data frame validation schema, and then use the schema object, as you can see at the bottom, to validate against new versions of the data frame that come in, right? Because you've declared in Python code exactly what your data are supposed to look like, what you expect about that data, and you can validate them with Python code. So you can use them, for example, in test suites. If you go down one slide, you can use them you can use the schema inside your test suite, as I'm showing over here. So we call this test time validation, or you can do it in like runtime. So for example, as you load the data, they'll come in and you'll do other stuff with it. And you want to validate that the data are correct before you do that other stuff. So Pandera, there's the link for it. Great Expectations is another tool. I actually got in touch with the Great Expectations developers early in the year after Ann Arbor. We did a call. They were gearing a slightly different use case. I think it was more data engineering-ish. So that call didn't really pan out. And then Pandera came along from the SciPy talks this year. And that was amazing. It was super, super exciting for me to see that. Now, if we go on, there's still some more that you can do with respect to automations. I've hinted at this before. You have continuous integration tooling from the software development world. They can do things like automatically executing tests. If you go on to the next slide, CI systems can be also repurposed to programmatically execute notebooks. You can do things like Jupyter NB convert and add an execute command on that as well. And if your notebooks are something you depend on, then you should probably automatically execute these analyses. And then if you go on to the third thing, like CI systems, if you need to continually update these model artifacts, like your pickle files or Excel spreadsheets or these dashboards that you're building, like Streamlit dashboards or Plotly dashboards or panel dashboards, you can actually leverage a CI system such that you've got everything sort of worked out correctly, and then you get push to your repository origin, and the CI system will pull in the latest changes. Once you've programmed it once, it just works forever, assuming, of course, your compute infrastructure doesn't fall underneath you, which has happened with our DevOps team before, but I forgive them. They're under a lot of stress. There's security issues they have to worry about, and their time is being sucked. But anyways, I digress. So that's the fourth principle: investing in a lot of like shortcuts, automation, saving from everything as small as like saving keystrokes at the computer to things as big as like system-wide, where you just have an automated runner continually running and checking stuff, continually building stuff and exporting stuff for you. Super important piece of like helping your data projects run faster in the long term. And the final thing I want to encourage about this fifth principle of defining a single source of truth. And what do I mean by that? So here's some examples on the first slide under here. One source library. So one defined source of truth for a particular function that does stuff. Don't copy functions from one notebook to the next, and then lose track of which one is the actual one that you want to rely on, right? Second example of this: no copies of data wherever possible. If you need a cache, it's got to be like in this place where you know you don't trust that cache to always be the most up to date. But as far as possible, minimize the number of copies of your data. Here's the next one, is one that really gets me going. As far as possible, don't have your colleagues, if your colleagues are trying to be kind-hearted and save you time by offering to, oh yeah, I can just calculate a new Excel file for you, and it's derived off that first Excel file, and I'll just do this extra calculation for you and give it to you. As far as possible, try to turn them down. They've got good intents, but it's going to lead to messy provenance of which data source you're supposed to trust for certain pieces of data. And it's happened before where we've had a proliferation of CSV files, and I go back and I can't remember which CSV file came from which other CSV file. And then I look at the two CSV files and then realize, oh, one's just a pivot of the other. Why did we even bother creating a new data source? We should have just done the pivot in memory live every single time. It's faster that way. It's easier to keep track of, right? So it's great for prototyping, but you should very quickly offer to translate all of that stuff into Python code so that your colleagues don't have to give you messy, so that you don't end up with a tough to provenance source of data. The next one is one of my favorites. If you have defined data sources, then I would also encourage you to develop shortcut functions to data. This is a tip, that like workflow piece that straddles both the fourth and the fifth principle. So if you have a data source and you know that it takes 2 or 3 transformations to get to another form of the same data, I would encourage you to write functions that do some stuff. First off, write data loading functions, and then write other functions that build upon that and give you a shortcut to the transformed piece of data. Let's see an example of this. So on the next slide, you'll see here's a data loading function that says, let's load some raw data. We'll pull in a file from the internet because that's probably how it's supposed to work. Or if it's on your shared file system, you load it from there. It's actually pd.read CSV. My apologies. I didn't even write that properly. Let's move on. I'm not trying to hide that, but look at that. So the raw data might be really important, but then there might be some transformed data that also really matters. And you might have to do some transformations on the data before you can use it for a particular purpose. And what you can do here then is write a shortcut function, a Python function that gives you a shortcut to that data. And now I've experienced this with my intern. He and I have tried managing SQL views. I don't know if you've tried doing that. That's a pain, right? And if you want to update the SQL view, suddenly you have to like recalculate everything, and it's like just crazy. But then we realized our data is small enough that we could just cache them locally and then write data loading functions on top of the cache, and then just program our computers to automatically refresh the cache every night, right? Every night we pull in a fresh copy of the data. And then suddenly we went from worrying for entire hours of the day about whether we got the SQL view query correct to just managing Python pandas code. Join it this way, drop this, select a bunch of columns, bingo, we're done. Now suddenly we have a Python function that gives us a shortcut to that data. We've like gone from hours to like minutes of development time. So these shortcuts help a ton, and they help a ton not only for speeding up our productivity, they also provide a catalog, a defined source of truth. My data.py file, which contains this function that you're seeing on the screen, will also contain doc strings that tell me the provenance of the data, why the data transforms were done, what the intended use of the data frame is. So it's a very nice and lightweight catalog of relevant data frames that are important for the project. Okay, so that's another piece that I want to encourage you all to try. There are other tooling for that as well. So for example, intake is an alternative, and it works on a little bit larger scale. So if you're not like on a single project with 3 people, oh my, this is going to get noisy pretty quickly. One moment. Our robot just started. Let me send it back. Let me pause it for a moment. My apologies. There we go. Kedro is also in part of this, like trying to work. Sorry, the Kedro devs also worry a lot about like data provenance, pipelines, and all of that good stuff. So you can see how what I'm suggesting can be perceived as a bit hacky, and I totally acknowledge that. So Kedro tries to be a bit more principled. If you're willing to invest the 5 or so days to like learn Kedro, it does take about that amount of time, as I've personally experienced. And you find it's going to be worthwhile, that trade-off is going to be worthwhile, then by all means go for it. But if you're not willing to do that right now, there is a very lightweight practice that you can already adopt. It's data loading functions with data tests. Moving on, you should be providing one source for documentation, so people don't have to go to this Confluence page, to that SharePoint site, to this Markdown file, to that other piece on the web. You provide a piece on the internet. You provide one authoritative source of documentation for the project, even better if it's version controlled. And in that way, it makes it so much easier for a newcomer to come in and figure out where all of the relevant pieces of that project are. So in terms of docs generators, if we move on 2 slides down, there's my favorite nowadays, which is MakeDocs plus MakeDocs Material. Uses Markdown primarily. You can use Sphinx if you're a little bit more well-versed with that. It's taken me a little bit of time to learn Sphinx, so I don't recommend it as like the beginner piece, but if you want to be pretty lightweight, then you can use MakeDocs, for example. I definitely encourage you to include documentation builds as part of your CI pipeline. So if you do that, then your docs are always going to be up to date. And in fact, if you use MakeDocs Material, you can get beautiful websites like what I show below. Network Analysis Made Simple is one example. It's got search. It's got plots, executable notebooks that you can view the outputs of on the next slide as well. Sorry. So those are really cool. And just to tie things back, I want to go back to like, if you go to the next slide, there's this one line that gives you the docs build. And I just include that line as part of like my local building of the docs so I can preview it, and remote building of the docs so we can see it on a remote machine or on a CI pipeline. Okay, so moving on. May sound like, holy smokes, there's a lot, right? Like, damn it, am I supposed to do everything tomorrow? And my encouragement to you is, no, you don't. what I want to encourage you to do is to pick up one practice and let that habit build over time. Keep in mind, it's taken me 5 years since grad school to come to the point where I think some of the software tooling it's taken me 5 years since grad school to slowly incorporate more and more software development practices that have actually accelerated my work. Don't tell anybody at work. I hope nobody at work is attending today, but I actually find a lot of time to slack off because I'm not worrying about checking things by hand, right? I can dedicate my brain power to more interesting problems like, well, graph neural nets. That's what really occupies my head nowadays. And I don't have to think so much about like the nitty gritty because I've just automated all of that stuff away. And so by adopting these workflow practices into your data science projects, they build up over time. You find that the amount of work that you can handle because you've abstracted away and automated away and just made habitual these good practices, they really elevate the amount of and quality of work that you can deliver, okay? Let's go back to Liebig's law of the minimum. It's on the next slide. I'd say that this law, I've come to realize, does really apply to our data projects. There are things that are going to be rate limiting for us. And for us, rate limiting really means time limiting. So if you move on, your project, it's really going to move as far, as fast, or as high as the biggest factor rate limiting it will limit it, okay? So if we go 2 slides down, I want to encourage you to ask these questions that really prompted my exploration into, all of this tooling. It was asking the question, what slows me down? Am I manually checking stuff all the time? Oh, nah, there's something that I probably could write that automates all that drudgery away. So anyways, there's probably, if there's something that slows you down, there's probably a software development practice that you can adapt. So for example, next slide, manually checking the same things, automate it with a script, write a Python function. 2 slides down from this slide, data issues failing you, automate your data validation checks, right? Do you have unstable copy pasted code? Well, maybe you should refactor your code so that you can have this and test it so that you can have the guaranteed sanity that your code is working. Is your environment like really hard to reproduce because you installed this and you installed that and you forgot what you kept track of? You're forgetting what you need to install things. Well, declare it with an environment file, right? Write these declarative files that are lightweight that help you manage that complexity. Moving on, can you remember, are you forgetting how to do things? Well, that's why docs exist. In fact, that's why blogs exist, right? Because if you forgot how to do something and you learned how to do something, if you learned how to do something the first time around, you immediately write it down and you publish it as a blog, whether internally or externally, then you get a way to, 1, raise your own profile, 2, help others with their work and accelerate their work. And then if you add that into the documentation, the source of truth documentation for your project, then you make it really easy for newcomers to your code and your project to be able to follow up on and jump on with minimal fuss, okay? So those are the principles. They're on this slide. I'm not gonna go read them anymore. Now, there is an FAQ that I always get that I really wanna go through so that I don't get these questions in the Q&A. So if we go on to the next slide, Priyanka. And so the first one is an objection that I always hear. I don't have time to adopt all of these practices. My response to that is, well, sorry, you will have even less time and many more fold stress if you don't. And trust me, I've been there before, and it's really not a good feeling. For which the next question that comes in is, where do you find the time to adopt these practices? Well, like I said before, you build them in one by one, you find the small wins for the relevant pieces, you build those wins into your workflow, you get that win, you have an extra chunk of time where you can breathe and you can deliver stuff of higher quality, you get back that time manyfold, and you get what I call credibility points. And this is related to the next point. So your clients, for example, won't give you the time maybe to adopt these practices wholesale. So what do you do then? Again, it's all incremental, and it relates to credibility points. You deliver what they want first, gain some credibility points, and reinvest those credibility points on asking for time to build reliability when reliability is an important piece of the project. It builds a virtuous cycle. Your clients, so to speak, come to recognize, yeah, okay, you've done something really good. I want more of it, and I want it on a regular basis. They're going to give you the time for that. I can guarantee that, unless you're in an unreasonable environment, of course. If that's the case, stick it out. I would oftentimes say just quit, but now this is not the economy for that, because in a chooser's place, in a chooser's market, like a data scientist's market, I would just encourage you, find a better place, man. Like that organization doesn't really understand data, doesn't understand and appreciate good practices. I'm not sure you want to spend your life being wasted on this kind of environment, but in this day and age, I think stick it out for the time being. Hopefully there's opportunities to be able to educate your colleagues on these practices and why they're important. Okay, and with that, I like to go to the final slide and say thank you for listening. My apologies, I did go over time, but there's been a lot in my head and on my heart that I want to pour out, and make sure that data science teams can really move faster, be more effective, have a lot more fun, eliminate lots of drudgery. And I want all that good stuff for you all. Right. So if you want to keep in contact with me, my website is on the slides up there. So you can always check out what I'm up to up there. And all the relevant links from my website are out there too. All right, so thank you very much. Right. Thanks also, Priyanka, for being an awesome presentation controller.
Thank you so much, and I apologize. I think I was moving too slow and too fast at
different. No, not at all, not at all. We didn't even rehearse this, so that was amazing. That was really cool.
All right.
I do see some comments and questions.
Yeah, but before that, I just wanted to highlight. So Tyler has just posted in the chat about a Google form, which is for the book raffle. So we would appreciate everyone signing in, clicking on that link and going ahead and showing their interest. So we have two books. One is the book, the network analysis book that you talked about, and then another one is Effective PyCharm. So we will have in total of 2 copies each. So I should say 4 in total. And then, yes, now is the time for Q&A. We would have Eric, anybody can post questions on chat, and we would have Eric answer them one by one. There was one question I think that I also asked. It went off, I don't know where. So I think my question was, to begin with, do you have this structure? So I mean, it looks like something that has evolved for you, or it would evolve for anybody. But how do you inculcate this habit in the beginning? Like, do you already have like a basic structure that you want to start with, that you suggest everyone should start with when, whether it's about folder structure or README, at the time of starting a new project? Or is it okay to, keep adding folders and notebooks and everything eventually?
Yeah, so let's see. I think if you take what's on the slides, that's a very lightweight starting point. So there's one of the slides inside there has like everything that's relevant. It's one of the last slides in like the one-to-one mapping slides. That's where my mental model is. And I do know that, at least in my head, I've memorized notebooks, data, source, README. Those 4 are like the bare minimum, plus my environment.yaml file. And then everything else I can like sort of build in as the project complexity requires it. And I think, who is it? Andrea Pierre did make a comment that cookie cutter is like a little bit, what do you call, fixed, or it does enforce too much once you stuck to a structure. I think that's the point. So there's a cool tool called Copier. I actually haven't heard of it, so thank you, Andrea, for sharing that. And I think it's a great, like, the tools that help us automate these pieces are really great as well. Though I think at the same time, we probably want to develop over time an awareness of how, an awareness of like what a sane structure, and one could maybe even say a taste for what a sane structure would look like, right? So for example, user space notebooks wasn't something that I originally had until I realized I was going to work with 2 or 3 other people. And that's when I thought, oh, well, maybe we should give user spaces underneath the notebooks directory. But user spaces for source code doesn't really make sense because we're going to be sharing the source code. So there's no such concept as like Eric's functions in my source.py, right? Like we talk together and try to make sure these functions are well organized in the source code. And it's actually been a few times. I've got really great interns. I'm so happy about them. An intern comes in, writes a function, and then a few months later, I go back in the source code and like, I think there's got to be something written that does exactly what I want. And true enough, Arkady has written that function, and I don't have to write it for myself. And he's documented it, and he's tested it, so I can like completely trust that that function works exactly as it is. So yeah, that's we sort of build it up, and we work out together what makes sense. And I think the taste of what makes sense is pretty common amongst most people. So hopefully that answered your question, Priyanka.
Yeah, cool, it does. Thank you.
Let's see. An had a question. Any tools for showing DAGs? Yes, actually that's one of Kedro's strengths. I haven't had that complexity yet in my own projects, but I do have colleagues who have it, and they swear by Kedro. So definitely check out Kedro for that purpose. And then another question from Anne was, do I have a tutorial that incorporates all of these practices? Not yet, but I would love to write one, hopefully collaborate with others on it. That's part of the whole trying to live out what I preach, right? Like, you know, do the open source education thing, teach people, help elevate the field with these open source materials that are out there for teaching. So yeah, I'd love to work together on that. And then Anne has another question. Exploratory work with the end products not known from the start. Do I categorize them into exploratory versus productionized deliverable ones? Do I apply the same standards for both? Right. Those are really great questions. And I can tell you, it's an open secret for me that I have a Scratch environment in which I prototype things. There is an environment file for that. So it's pretty well defined. And I know that anything inside there is guaranteed to work with each other. And there's been like this exploratory statistical methods paper that I've been trying to get written that started out actually inside the Scratch environment and had zero structure. Like it was just notebooks. If you look at the structure, it was flat. There were a bunch of notebooks. There was a Parquet file. There was a CSV file. There was a NetCDF file. There was Python scripts all in one place. And it was a mess. And actually, I suffered when I sort of had to drop that exploratory statistical methods thing for a few months and then come back to it. It's only been a few months. The only thing I could remember was notebook 5 because I put 5-something.ipynb. That was the thing I was primarily working in. And everything else was a jumbled mess. Okay, that speaks to why you would want to put sane structure for every project if possible. But of course, if you're just like, I'm acting on inspiration, well, be ready, of course, then mentally ready to pay the time necessary later on for creating, for imposing structure on it. And you're going to lose some things in the process. Like there's some scripts that I just don't know how to connect to everything else in the project. They just go into this they go into the folder called dump. And someday I'll look at it again if it's ever relevant, right? So I would say, encourage you to try to hold yourself to the same standards for exploratory and productionized deliverable projects. But don't bang yourself up if you fail to, because, you know, if you're in an okay environment, you'll have time to worry about that later on. And I think the other one is, how often do we refactor our code? I refactor code as soon as I copy paste it. So as soon as I catch myself copy this code block, and I'm just going to paste it inside the other notebook, yeah, that's the time to like refactor. There are people who are not as strict as I am. Some will say, I've got to copy it 3 times. That's when I really know I need it in multiple notebooks. And so then that's cool as well. Cesar has a question, when you should be pinning. Oh, Cesar, so in chat, so for the benefit of those who are watching the recording, do you have any preferred, any recommendation for when you should be pinning the version of your packages? My usual workflow is not to set up any version, create the end, then pip freeze our conda list, then copy and paste that in the conf file. Is there a better way? I don't know of any better way. That's exactly how I do it. So you're like, you're with me, I'm with you on that one. And Cesar has another question, which is, what's the preferred package for creating dashboards? Been playing with Streamlit, but wondering if I have some other preferences. I've actually played with a large range of them. Streamlit is conceptually the easiest, but it's also, I found programming model-wise, it's the easiest to get up to something that you can present to others. It's kind of a pain to maintain long-term. But then again, building dashboards, or building, I guess, applications off, you know, data-driven applications off. I think that really we should be enlisting the help of a proper UI UX team, software development team. Data scientists can try and build the prototype. Streamlit's great for prototyping, and I've used that. I've used Panel as well to just get prototypes out. I've actually had one experience. It's an automated chemistry machine learning thing. I built a prototype of what the front end should look like. It was enough to shape up the project, and now there's like 5 or 6 engineers working on that with the product owner to take that to production. So Streamlit's great. Just start with that if you want something up really quickly. Venkatash is asking, as remark, viewing the topic through the software engineering lens, DS is going through a knowledge consolidation phase as more and more folks work on DS projects and identify issues plus opportunities to improve the data science workflow. So this is very similar to what software engineering went through the last 2 decades and led to books such as The Pragmatic Programmer. And I'm totally with you, Venkatash. I think it's super important that we get our workflow practices in order, because then that will help with the velocity of what we're going to do. And I really want to encourage everybody to sort of develop a taste for tooling that is lightweight enough to incorporate into your workflow, but also able to provide multiple fold of benefits relative to the heaviness of that tool. So develop a taste for that, and don't be too quick to develop things. I didn't adopt these practices and tooling at one shot, did incorporate them and try to make sure that they made sense in my context. So there's a few others. There are a few other tools that have shown up. I know Tyler's saying we probably have to close up right now. Yeah, I think I want to thank everybody for coming once again. Thanks again to the hosts of the Meetup. I've actually been at the Meetup in 2013 and then been through the ups and downs that the PyData Boston has been. Hopefully there'll be more time in the future that I can come back and hear more great stuff from everybody.
Awesome. So we definitely want to give a huge thank you to Eric. This was awesome. And definitely, as being in a company that's going through some analytic transformation, I feel like these practices are things I'll be definitely taking back to my team and sharing with them. So I'm excited to do that. So big thank you. And I'm sure be a big round of applause if you're all in person. One thing that I just want to mention, kind of going off of that, a few action items for the folks still on the call. Definitely sign up for our Slack group. We want to stay connected and be able to continue to drive and share ideas across the group. In addition to that, take a look at Eric's stuff that he's able to share. Definitely feel free to share his content. Continue to mention what you liked about the talk. Definitely, we want to continue to grow this group, and we definitely appreciate everyone continuing to participate. And really leading to our last piece is call for speakers. We're always excited to kind of push other people's ideas and definitely get behind them. I think this was a great talk. And if you also agree and you have another idea, feel free to come back. And folks, feel free to continue to build this community. There's one more mention, and I think we mentioned a little bit earlier. PyData is doing a global conference. It's going to be virtual. That's going to be super cool because these conferences are usually located in like New York or some other cities. So everyone's going to be able to be part of this. So huge opportunity for that. But with that, again, thank you, Eric. This was awesome. And thanks everyone for joining.
All right. Thank you, everybody.
Thank you, Eric, and thank you, everybody. Bye-bye.